Hey guys, we are in our free online coaching classes for the NET examination, and in this video we will try to understand actually what determines the possibility of conventional rainfall. And this video will be the lecture 7 in this series, and the topic is the Lapse rate. And the book which I referred for the topic is The Atmosphere, Ocean and Climate Dynamics by John Marshall, The Climatology by John E. Oliver, and The Atmospheric Thermodynamics by John M. Wallace. And this topic is in the fourth heading, that is in the Ocean and Atmosphere. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading. The Lapse rate is defined as the decrease of any atmospheric variable with height, and the variable being temperature unless otherwise specified. So whatever the variable that is changing with the height, that can be that can be defined under the Lapse rate, and if it is not specified, then the Lapse rate simply indicates the rate of change of temperature. And this thing can be mathematically expressed as gamma is equal to minus dt by dz, where gamma is the Lapse rate and T is the temperature and Z is the altitude. And it is indicated with the negative sign because as we move higher there is a drop in temperature, and that is why we are using the negative sign in the front. So the Lapse rate can be expressed as the rate of change of temperature with the altitude. And this is further classified into two types, that is whether the rate of change of temperature is on a stationary atmosphere or in a moving air mass, that is the environmental Lapse rate, that is actually the change of temperature with the altitude, that is for a stationary atmosphere, that is the air mass should not move, only there is a rate of change of temperature along with the height. That will be called as the environmental Lapse rate. And the adiabatic Lapse rate is the change in temperature of the air mass as it moves higher. That is, when the air mass is itself moving to height, so there will be change in temperature, and that is called as the adiabatic Lapse rate. So the environmental Lapse rate indicates the air mass is stationary, and the adiabatic Lapse rate indicates the air mass itself is moving. And this adiabatic Lapse rate is further divided into two: the dry adiabatic Lapse rate and the saturated adiabatic Lapse rate. That is the moving air mass, whether it consists of water vapor or not. That is, if the moving air mass is consisting of water vapor, then it is called as the saturated adiabatic Lapse rate. And if the moving air mass doesn't have any water vapor, then it is called as the dry adiabatic Lapse rate. Is that clear? So let us have some detailed knowledge about the dry and saturated adiabatic Lapse rate. The first one is the dry adiabatic Lapse rate, which is called as DALR. Is the rate of temperature decreases with height for a parcel of dry or unsaturated rising adiabatic condition. Is that clear? So what they are saying here, the air mass is rising higher, and this air mass doesn't have any water vapor, and that is why it is called as dry or unsaturated. And the adiabatic means without loss or gain of heat during the movement. And what happens when the air mass is moving higher? There will be a drop in pressure, right? When the drop in pressure, what happens? The air mass will try to expand, and as the air mass expands, it will lose its internal energy. As you know, when there is a drop in pressure, so automatically there will be a drop in temperature, and this drop in temperature will be in the range of say 9.8 degrees Celsius per kilometer. So this is the overall adiabatic Lapse rate. Is that clear? So as the dry air mass moves up and the pressure drops at the higher level, the air mass try to expand. And when the air mass expands, there will be a loss of internal energy of the air mass, and that leads to the temperature loss. And this temperature loss will be somewhat near 9.8 degrees Celsius per kilometer. Is that clear? So the second one is the SALR, that is the saturated adiabatic Lapse rate, and that is actually strongly variable with the temperature. So let us give you a average value, that is a typical value of the saturated adiabatic lapse rate is 5 degrees Celsius per kilometer. If you compare these two things, that is the dry and the saturated, you know that the saturated adiabatic lapse rate is very less, that is just a drop of 5 degree per kilometer, whereas in terms of dry adiabatic lapse rate, the drop is 9.8 degrees Celsius, that is almost twice than saturated. The reason is that the saturated air mass consisting of water vapor, right? And when there is a drop in pressure, this water vapor will try to condense, and that condensation leads to the supply of heat energy to the air mass, and that is why the dropping is very less here. Whereas in terms of dry adiabatic lapse rate, there is no any water vapor, so automatically there will be no any condensation takes place, and that is why the rate of drop of temperature is twice higher than the saturated adiabatic lapse rate. Is that clear? When the air mass is dry, there is no water vapor, so the temperature drop is higher. Whereas in terms of saturated air mass, there is presence of water vapor, so that will automatically condense and that releases heat, so the drop is very less when compared to dry adiabatic lapse rate. Is that clear? So if you are clear with this, we will see the application of lapse rate, where actually we have to understand something. Actually, the varying environmental lapse rate throughout the Earth's atmosphere is of critical importance in meteorology. So whether the rainfall, according to the meteorological studies, the lapse rate is quite important, and that is also within the troposphere, because most of the rainfall is from the troposphere, right? And that is why it is important. So let us see one after other. Actually, the understanding of lapse rate will help us to find up to what height the rising air mass will reach, right? So if the air mass will rise higher enough to condense the water into cloud, or even the air mass may rise further higher to form the shower cloud, or whether the lapse rate will let the air mass to rise even further higher to form the bigger cloud, that is called the cumulonimbus cloud, and that forms the thunderclouds. So all such a thing that is determined by the lapse rate. So up to what height rising air mass will reach, that can be totally controlled by the lapse rate. So let me explain you this thing with an example. So the first thing is that when the environmental lapse rate is lesser than the saturated adiabatic lapse rate. So in this case, what happens when the environmental lapse rate is lesser than the SILR, the air mass will be absolutely stable. And when the air mass is absolutely stable, what happens? There will be the formation of cloud is totally unlikely. So when there is no formation of clouds, the rainfall will be not happening, right? And this is what actually happening in the early morning on the land, many land. Okay. The second case is that when the environmental lapse rate is larger than the DALR, that is dry adiabatic lapse rate. In this case, what happens? The air mass is totally unstable, and when the air mass is totally unstable, the condition may be likelihood of shower or even the thunderstorm is very high. And this case is in most of the landmass at the afternoon time. So this is the actual reason for the conventional rainfall, and this is how the conventional rainfall takes place. That is, when the dry adiabatic lapse rate is very smaller than the environmental lapse rate, then the air mass can rise to very high, and this rising air mass may leads to the thunderstorm or shower, whatever up to what height it reaches. Okay, and this is how the conventional rainfall is taking place at the afternoon time. I hope I explained the reason for the conventional rainfall, and if you are not clear, just feel free to mention it in the comment section. We will do a special video on that topic. And I group my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook and Instagram, and these are the links. You can support us by like, share and subscribe. Thanks for watching. Have a great day.